Hey guys, Mr. B here, making a video from home. Just wanted to go over some of the definitions for our project. Here is a list of all the definitions you need for project 2. So just so you know, if you find your definitions online, I'm going to let you get very close to what's on the internet as a definition. Because it can be hard to come up with, to write in your own words a definition. So as long as you cite your sources, you can use the internet to help you with these definitions. But I also want to talk about them myself so that you can have me explaining them, and that might help you, I think. Okay. So the first one we're going to talk about is this one, atomic number. Now we've talked about this one before, but let's go over it again just to be sure. So if we go in here to the periodic table, zoom in, we're going to talk about hydrogen. Hydrogen, as you remember, is a really simple element that we've talked about with water and other things before. Atomic number is important. It's this number right here, okay? In all of these different elements, it's the number in the tile that's like the upper left-hand side. You can see it down here as well. That number is the only thing that matters for the identity of the element, and that is the number of protons, okay? Very fat writing, but you can kind of read what I'm writing. Protons. So that means that lithium right here has 3 protons. Okay. Sodium has 11 protons. Hydrogen has 1 proton. So that's all the atomic number is. It's just the number of protons, and it's going to be in the upper left-hand corner of all of these different symbols, or all these different elements on the periodic table. And yeah, that's important because it's the only thing that matters in identifying the element is the number of protons that it has. Okay, now let's cross that one off. Let's talk about atomic weight. Okay, let's go back over, oops, I know what that's doing. Let's look at, this is a little hard to see because it's kind of pixely. It's making me undo a bunch of stuff here. Okay, here we go. Let's look at carbon, actually. So carbon has an atomic number of 6, means it has 6 protons, but it has an atomic weight of like 12.01. It's a little hard to see, but 12.01. The atomic weight refers to, in the simplest terms, it refers to the number of protons plus neutrons. So the number of particles in the nucleus. Carbon, it's approximately 12, but it's a little above 12. That means sometimes there's 13 particles in the nucleus. You remember, every single carbon has 6 protons. So what does that mean if there's 13 particles in the nucleus? That means it has an extra neutron. Okay. So carbon 13 has 6 protons and 7 neutrons instead of a normal carbon that has 6 protons and 6 neutrons. Okay, so atomic weight, all it is the average number of particles in the nucleus of a different element. Okay, so there's that. Let's get rid of all these. All right, great. We have atomic weight. Now let's talk about melting point and boiling point. These ones are pretty easy. You might remember them from other science classes you've had. So let's say that you have something that is made of pure, let's go with carbon. Pure carbon. That substance, or any pure substance for that matter, is going to have a certain point, a certain temperature at which it melts. So that's what melting point is. Water has a melting point of 32 degrees. So like, if it's 32 degrees Fahrenheit outside, that's about when water starts to freeze. If it goes above that, it stays water. If it goes below that, it turns into ice. So that's the melting point of water. Boiling point is similar to melting point. It's the point at which a liquid starts to boil. Okay, so liquid water has a boiling point of something like, I think it's 212 degrees. I don't remember exactly, 212 degrees Fahrenheit. So if you heat water up to 212 degrees Fahrenheit, it's going to start to boil, turn from a liquid into a gas. Okay, so that's all those things are. Pretty simple. So yeah, let's get rid of all this stuff. Okay, melting point and boiling point done. Now let's talk about period number and group number. These can be a little confusing. So the first thing I want to talk about is the difference between columns and rows. We're going to be talking about the periodic table in a second here, but I want to talk about what columns and rows mean first. A column is something that goes straight up and down, okay? That is a column. Column, and that's how you spell column with an N at the end. And a row is something that goes side to side like this. You spell row like this, okay? When we're talking about period number and group number, we're talking about the different columns and rows in the periodic table. So periods are the rows in the periodic table. I think about that like this. If you draw a P next to the periodic table, imagine it's got a little eyeball and he's looking across the periodic table, okay? So for instance, potassium right here is in period number 4, because you go down 1, 2, 3, 4, and then this whole period right here is period number 4, okay? Get rid of some of that stuff so we can see. Now how about sodium? What period number is it in? It's in period number 3, okay? All the way across. Magnesium's also in that period. If we go over here, silicon's in that period, phosphorus, sulfur. So that's what a period is. It's the row, the row that an element is in, all right? Now let's talk about groups. Groups are the column that an element is in. So here's your group numbers up here. Columns, you'll remember, go up and down. Periods go side to side. So here are the different groups of the periodic table, all right? So remember I said sodium was in period number 3, but it's actually in group number 1. See how that works? Now let's think, what group is silicon in? Silicon is in group number 14, okay? Boron, how about boron? Boron's in group number 13. So you see how that works? It can be a little confusing to remember. I just like to remember that period has an eyeball and he's looking across the periodic table like that. And the reason why this is important, why chemists talk about periods and groups, is because elements that are in the same group in particular have similar qualities. So for instance, carbon and silicon are in the same group. They're both in group number 14. They have similar bonding patterns. They form similar types of elements. They do lots of things similarly. Same with like beryllium and magnesium, or fluorine and chlorine, all because they're in the same groups, all right? So that should give you an idea of period number and group number. You can always talk to me if you have more questions, and yeah.